Okay, good morning, everyone. So today, let's start our lesson now. Could you please turn on the camera? Now we come to question 14. We have got a recap of fats and oil and also detergents. Okay, fats and oil and also detergents. So take a look on page 220 on the chemistry of organic compounds. So as we still haven't received any updates from the EDB about the coming summer holiday arrangement, we just need to. But for the time being, if we can, I don't know where. But you know, my common practice is that during summer, I also have supplementary lessons with you. Okay, in the real summer vacation, we still have. So if you go back to the to this special situation this year, if we delayed the start of the of term 2 again, okay, and let's the lesson continue until July. You may know that the original summer has gone, but we do not have much chance to cover the essentials in the preparation of your DSE. So what is the hidden message? You may have the supplementary lesson during this summer holidays. Okay, but we need to receive the EDB notice. You follow the school instructions before I can set a day with you. Okay, so this is our announcement to all of you. So shall I remain some others to turn on the camera? I see half class have opened it. Good. How about the others? Could you please do it now? Thank you. Now, question 14. Triglycerides. They are triesters. They are found in fats and oil. The structure of this, it will be this. It's hydrolyzed with with hot aqueous NaOH. So you are asked for the name of the alcohol that is formed, name of the alcohol that is formed from this hydrolysis. So what is it? One year long. One year long, are you here?
Yes, I'm here.
Yeah. So what is that? What is the name of the alcohol?
Propane 1, 2, 3 trial.
Propane 1, 2, 3 trial. Can we say glycerol? Can we say glycerol?
Please systematic name.
Now, so you take a look at the term systematic name. So what is the difference? Now you will write down propane. Now, first of all, we have got an E here. Okay, hyphen 1, 2, 3 hyphen trial. So if you write down glycerol, it's not accepted. But what we call the glycerol, it is a common name. Okay, it is a common name. So this is what you should be aware of. Okay, so you draw the structures of the other organic products of this hydrolysis. Other. So according to this structure, what can we do to this? So how many types of the other products will be formed, right? So besides propane 1, 2, 3 trial, what will be the other products? How will you split that? Which part will tell you a component of glycerol? Which part? Okay, it's here, right? This glycerol. It's glycerol. So what should we do? Now, next. Can you show me how we can know the structure of other organic product? What should we do? Where are the esters? Where?
Linked by the oxygen atom of the
Okay, with the CO, right? COO. So you are going to check COO. Okay, first of all, what's next? You're going to cleave the ester linkage. Cleave the ester linkage. How? Like this. You may do that tricks, right? You may do that tricks. 3. Remark those all those as glycerol. You know this is glycerol, right? So, but for each red circle one, we call it hydrolysis. So, which means we add back water. So, what is leaving behind is OH. Can you get my point? So here comes the other substances. Just copy these, this, and also this. Now, of course, if you check that too, they are equal, right? But for this one, it's different. Now, on the left-hand side, it's different. Do you realize? Okay, so check it. That 3 underlined in blue, they are fatty acid, right? But is it? Is it the answer?
No sodium.
Sodium. So you take a look at the term hydrolysis. What type of hydrolysis we are having?
Alkaline hydrolysis.
Yes, alkaline hydrolysis. So what should be done next is to change a little bit for the exit. So you are going to have that COOH, right? You are going to add it as an alkaline, so you will get it as CO minus, right? So you use this framework. Okay, you use this framework for help. Now we would go back to this. You need to make a little bit adjustment. It's not H. It's not H. Okay. Instead, I add what? I add Na plus. Okay. Remember COO minus. This COO minus is the same as this. Now you do something similar. Now first change is on here, right? While you tackle how you tackle the way when I draw the organic substance like this way, CO minus Na plus, right? On the right hand side, that too seems to be quite strange. But remember that Na plus, the plus sign, the positive charge should also be put right onto your right hand corner. But Mr. Chin, how about that? Oh, we cannot, right? Because you are now putting that O with the connection with carbon later on, so you rather confusing. Is that and that negative charge will not be seen so easily. So you may see people will write down CO minus like this, right? The minus is here. Otherwise, if you write down the COO and then O is minus, it is rather confusing, right? It's rather confusing. I don't know whether or not that line refers to the charge or the bond. So we will seldom draw it like this way. Is that clear? Questions? You understand? You understand the approach? So don't worry. In your exam, it's not always to draw the structure of glycerides as this, like a E shape. Now it can be this. It can be this, right? If so, what should be done? Now is to one of the methods to solve is to identify the major component responsible for it is glycerol, right? First of all, spot for me the glycerol part, and then you will soon find the triester. What are the 3 ester group here? It's just next to that O, right? The O is included into your ester linkage. And what should be done next, right, is to cleave the ester linkage, and you're going to add back HNOH if you want to talk about acid hydrolysis. How about alkaline hydrolysis? You are going to twist a little bit. Chen Huiting just asked if the reaction is acid hydrolysis. So what is that? So it is the first version that we have just written, the glycerol and fatty acid. But if it's alkaline hydrolysis, the answer is glycerol and the sodium carboxylate salt. Okay, is that clear? So we have got the 2 versions. So remember to be aware of the material to make that hydrolysis. Is it acid or alkaline? Understand? Is it acid or alkaline? So you need to be highly aware of it. If it's acid, the answer is COOH. If it's alkaline, the answer is COO minus Na plus. Questions? You got it?
天 Sir 其實唔係想問一問嗰、個，即係嗰、個左手邊嗰個唔係應該有 strength 咩？
It's trans. Which one? This one? This one is trans, yes?
Yes,
So
yes.
the questions is trans, right? So what is the questions?
Oh, sorry, I understand now. Thanks.
Okay, so the answer, if you write down the answer for the organic product, okay, of the organic product, you still write it down like this, right? Because it already shows you it's trans. So if it's trans, you are going to draw it as a trans fatty acid. If it's cis, you are going to draw cis fatty acid. But naturally, okay, naturally, what is the common which one is more natural? Is it a cis acid or trans fatty acid? Do you know? Lei Cheng, something about common sense. Do you know?
即係點啊
cis fact, trans fact. Which one is more commonly seen, right? Or naturally?
trans fat I think
你死啦你！
我唔知啊，我真係
It's quite the opposite. 反式脂肪有冇聽過？
有啊有。
反式脂肪就係 trans fat 咯。咁幾時有反式脂肪啊？It will happen.
嗰啲 junk food 嗰啲啊。
Yes, junk food. Why? Because during heating, we usually heat the oil for long. Okay, just recall your memory about CC double bond. Here, if I undergo the bond rotation, right, about the CC double bond is restricted, normally at room temperature, right? But I heat the oil for long, what will happen? There may be a chance of a partial breaking of this CC double bond, so as to make it CC a single bond, and this CC double bond can rotate, okay? Which means this bond can rotate. Once I cool down those oil, right, at room temperature or just cooler temperature, the carbon-carbon double bond may be formed again. But it depends on what is the extent of rotation it is, right? If it is still rotate like this way, even though I temporarily break down the CC double bond, the second bond of the CC double bond is still that fact, okay? But if you twist a little bit, it will go to another type of fact. Now, this example, they will show you this one is a trans fact, okay? It's a trans fact. But usually, if you refer to the to our daily life, right? It is fact, not trans fact. How you know it now? So you may find fish oil structure. Now I would like to elaborate more on that. Listen to you take a look on this. Is this cis fat or trans fat?
Cis.
Cis. Okay. So if you write down trans, it will not be that way of writing. Those bulky groups, they are found on the same side of the CC double bond. So no matter is DHA, EPA, LA, LL, all those, they are just they will tell you something more about the fish oil. Okay, fish oil. Okay, it's very natural to have cis fat instead of trans fat. While trans fat is usually made by prolonged heating of oil, of a cooking oil. So that's why the cooking oil, once you use it for deep frying, you have to pull them away after a period of time of use. You know it, right? So trans fat is something bad to your health. Any questions? Usually it's fat. 順式反式啊。Now, you take a look on question 15 now. Now, very similar to your past paper type question. The equation below shows a sample of reaction used to make ester from vegetable oils. Then the ester, they are suitable to make it as a biofuel, just like biodiesel. Give the structural formula of the systematic name of a of compound Z. Again, same question. Same question. Is propane 1, 2, 3 trial? Do you realize? Okay, the same question. Systematic name, but not glycerol. You can never write as glycerol as systematic name. Now it is the common name. Just like nickname, right? Structural formula. So you are going to draw it as is a trial. Propane 1, 2, 3 trial. Okay, like this. Propane 1, 2, 3 trial. Now this is what you should be highly aware of. Okay. And B. Now you have to calculate. Very strange, right? C7H11 group. Give the number of carbon double bond. Just calculate. Monet, can you calculate how many carbon double bond are there? How you know the answer? Just what formula do you have in your mind such that you can calculate as 4? So originally, if all those they are just all those they are just carbon single bond. So we have got C7. C7, how many H should there be? Of course, you can draw 7 carbon with a full structure, right? You can count, but it is just abbreviation. Now there is a hidden formula where we will call it as a LQ group. LQ group, the hidden formula for the LQ group is
CN 加2
CnH2n plus 1, but not plus 2. Do you know why? I leave one bond for one hydrogen missing as to have a bond formation. So what's next? It should be connected to another carbon. So if you stick back to C7 and then do the formula and calculate C7H25, H15. This is the showing of all CC single bond, but not CC double bond. Can you see that? Believe it or not, you are going to draw something like this, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, okay? You will know, right? It's already 15. So it will connect to something else. We will call it as an alkyl group. Can you get my point? So why you will say that CN2N plus 1 is because you leave this bond for connecting some other things. So what will happen if I have got 4 hydrogen S? You think it backward, right? You think it backward. In case I have, irrespective of the position of the CC double bond, I just pick one as an example, right? If I put it as a CC double bond, of course, each carbon here is now pentavalent. Now you are going to remove some hydrogen, right? How many hydrogen atoms will be removed for making one hydrogen bond? 2. Can you make a guess? So here comes 4 hydrogen. So can you count it again? Tell me. How many carbon-carbon double bond is that?
係咪3個？
嚇，3個。
嚇
？3個 double， 3個 carbon-carbon double bond 係咪啊？如果1個 carbon-carbon double bond 冇咗2個 H 啊嘛？
兩個。
點啊？1 or 2， 喂 ，1 or 2 or 3， 你講得好高過4個有聽過。
兩個。
做咩？求其揀啫嘛，好似。
Now,
now, so you will think of another case, right? You have got that CC double bond, 2 CC double bond. Originally, we have got this one is hydrogen, right? I have get rid of 4 hydrogen. So the answer is 2. Okay, the answer is 2. 2 carbon-carbon double bond. But the question comes, do you know the exact position? If I write down C7H15, do you know the exact position of the CC double bond? No, it doesn't tell you anything about position. I don't know. I don't know the exact position. So you may have a different combination of that CC double bond in whatever position. I don't know. Okay, I don't know. Ester Y, but in the natural scenario, in the naturally occurring fats and oil, now you take a look on this. Okay, so we would find these two, the first two, DHA and EPA, right? This is the fish oil. Okay, and so you may see, we will call that omega-3. Can you see that? Can you see that? Omega-3. So what is mean by omega-3? Good to your brain. In case you will have your family later on, some years later, you better buy your babies some milk powder, right, with omega-3. Don't know how, what are the benefits? That too, chemical. Okay, DHA and EPA, they are just exactly the raw materials of making the membrane of the brain cell. Okay, can you synthesize inside your body? The answer is no. So you have to rely on the intake of the food. So do you understand? So that's why people would usually think of feeding baby with fish oil, right, while they are still small. That is the traditional wisdom. People in the past don't know why is it. But nowadays, here comes the answer, right? For the growth for the baby in the rapid speed, right, they need some raw materials, right, to make the brain function well. Okay. So, Leichen, do you understand now? Don't worry, don't worry. Your offspring will have a chance to be more clever than you. Okay. Remember, you have understood something about science and chemistry. Now, so you take a look on that, and as to why is more why you say that omega-3 is because of the 3 here. I forgot to tell. 3 here is you count from the terminal. Okay, we have got the alternate. We have got the CC double bond, right, at this position. What is that? The other position 3, 4, 5, and 6. Can you see that? 3, 6, 9. Can you count? Now it seems like every 3 carbons you will got the start of the name of the CC double bond. So we will not only tell it as omega-3 or 3, 6, 9, etc., right, which tells you the position of the CC double bond. 好多時都係。It is found in here. It's omega-3, which means that the fatty acid with that chain, you count the carbon from the terminal. Very strange, right? Isn't it? If you really want to call it as hexanylic acid, which means that you are going to count carbon 1 on the left of a molecule, but not on the right. Right? So that one you are going to count it in at the tail, right? It is from the terminal. You count it omega-3. Very strange. Okay. Questions? Now, ester Y is more suitable as a biodiesel than ester X as is a lower boiling point. Justify the statement. Why? Where is biodiesel? Biodiesel is here. It is the raw materials for making biodiesel. So compare their boiling point. Is ester Y has a lower boiling point than what? Ester X? Yes, that's true, right? Why? Lâm Seng Hon.
Because it has weak van der Waals force between its molecules.
Van der Waals force between the molecules of Y and that between ester X is different.
And also ester Y, the size of ester Y is also smaller.
Okay, so it is indeed the same flow of reasoning. So the molecular size, as we all know that the molecular size, they would affect the strength of Van der Waals force. So it will affect the boiling point. So whole flow of logic with this. So when you compare between X and Y, you can make a comparison. Y is smaller than X in size. Yes. And then the Van der Waals force, the strength of this, of course, is different. So the boiling point of this is different. Okay, in which Y has a lower boiling point. Just remember that logic. So you are going to follow this. You're going to follow this. Questions? No? Easy, right? How about this? Suppose I have got question. You may have got question 16, right? 16. Oh, the hydrolysis 1 mole of triglycerides give 1 mole of oleic acid and 2 moles of stearic acid, together with a propane 1,2,3 trial. The triglycerides is optically active. Draw the structure of triglycerides. Label the chiral center using star. explain how this glycerides can be hydrogenated. Oh, A is very strange. How will you draw the structure of a triglycerides such that it's optically active? Okay, your turn. Draw it and send a photo to me now. Can you draw me the structure of A for A and send it to me? Send it through the Cam1 class. Okay, what's that? Okay, while we are waiting, the steps of hydrogenation. I need what? Hydrogen gas. What else?
Catalyst.
Catalyst. What is a catalyst?
Platinum.
Platinum. Okay, platinum room temperature, or you use nickel. But you use nickel, remember to apply heat, okay? Or you use this, right? Platinum is just room temperature, is okay. Table finish. Drawing 16A. Can I have your work? Take a look. Mm-hmm. Mm-hmm. Good. Can you manage? How about the others? Ronald, could you please book a star on the chiral carbon? A is the chiral carbon. Similarly, can you just done half of them? You are going to label the parallel center. 里程 again that's your connectivity of the bond. Take a look on the work. Some others you can admire, right? His masterpiece. See where is the connecting atoms, especially for the vertical line.點啊你情？你玩嘢啊？attention seeking 我哋有。Oh, 35, 35, 33. Yes, that's correct. So once I ask you to get to know the importance of finding the chiral center, you may find that your fatty acid C17H35, you have got 2 mole of it plus 1 mole of oleic acid C17H33. But your answer for the fatty acid 3 ends, they are just the same, C7H35. One of them should be H33. Now, very interesting. You may see Li Zhaxing works. All of you, please take a look. Again 李程你都係搞唔掂啦。Again， 喂，馮家謙你都係啊。3 fatty acid with H35. No, one of them is H33. 2 of them is H35. So take a look on Li Zhaxing works. Okay, so this one is quite different from the others. Is it also acceptable to be answered by you draw this, right? Is it acceptable? So my question comes, is this one a chiral carbon? Now, first of all, if you mark the presence of chiral carbon, the carbon 2 of the glycerol must be the chiral carbon, right? You cannot think of hydrogen 1 or hydrogen 3. Now, because you may find carbon 1 and carbon 3 having 2 hydrogen. Can you see that? We have good whole hydrogen already. So this carbon, and this carbon must not be chiral. Now you take a look on this. Now this carbon is a chiral, so you take a look on group 1, group 2. That 2 is different. How about these 2 groups? These 2 groups, you draw it as the same. They are exactly the same. So only having this combination cannot tell this triglycerides being chiral. Can you get my point? So the H33 must not be put into the ester connected to the carbon 2 of the glycerol. Do you realize? So only this case is wrong. Okay, so you may count the C17H35 from top to below. It can be 553. Is okay, right? 553, 355 is also okay, but 535 is totally wrong. Can you get my point? So the carbon 2 of the glycerol can never be connected to the fatty acid of C17H35. Okay, otherwise it is a chiral this time. So you are going to make sure the 2 big circles being different. Is that clear? Okay, can you follow this one? Is this carbon chiral or achiral? Are you here? It's not chiral, huh? Remember, because for the top or the bottom circles, they are the same. Okay, is it clear? So you take a look on this. This question's about again, Li Cheng. Again, you take a look on your work. The carbon should be bonded with carbon. Could you please draw it again and send it to me? Li Cheng. Do you know what's wrong with it?
咩叫 carbon？
Carbon
哦，我都
be
核突呢個。
bonded with the carbon atom, but not in between. You just write
Okay.
down 2 vertical lines, but I don't know which atom is connected to which atom. 17. This question is about emulsifying cooking. Mayonnaise. Do you know what's mean by mayonnaise? You know what's that?
係咪蛋黃醬定係咩話？
蛋黃醬喂，一啲沙律醬嘛，其中一種沙律醬白色嘅。Okay, it's a thick paste. It's a mixture of emulsifier, oil, and water. So label the 2 parts of the emulsifier molecule. 逼下你串字啫，串字啦，梁家傑。Left hand side, what is that? .喂，唔識嘅21次啊？點啊？hydrophilic. Okay, so philic. 黃俊熙 on the right hand side.
HYDROPHOBIC.
How will you call it?
誒
What is that?
唔識讀啊。
真係
hydrophobic。
我真係要讀過，即係好彩要讀一次啫。嗱，我唔係陰你啊，即係逼下你哋要讀一次先啦。大家開咩讀一次啦？即係 read aloud 真係。叫咩啊
？hydrophobic。
hydrophobic，好，讀3次。
hydrophobic。
喂，第2次都讀唔到，咁搞錯啊 ！hydrophobic, phobic, phobia。OK, phobia, phobic. OK, hydrophobic. 好，黃俊熙 ，how about the one on the left hand side?
hydrophobic。
What is the difference between left hand side and right hand side? What is the difference? Hydro. 鄭明，你笑到咁興奮做咩啊？搞錯嘅。
係咯。
唔衰嘅。洪家謙，多謝。
Hydrophilic 係嘛
？Yes, left hand side. How about right hand side?
Hydrophobic.
Hydrophobic. Okay, hydrophobic. Okay, 得好收貨。So explain how an emulsifier helps to stop oil and water from separating. Explain how. 好恐怖啊！呢條題目好恐怖啊！唔講住，因為咧 B 嗰度全世界都要寫一次㗎，寫定啦，寫定啦，預備寫咯喎。第18 The structure of triglycerides found in olive oil is shown below. Olive oil can be used to make soap by heating with corn NaOH 又嚟啦。好，18 做完啦 ，send 過嚟啦。寫完又寫。Okay, this time post it into the Google Classroom. Now, this is an essay type question. I need to tell you the marks for each. 好唔抵答嘅，嗱呢個抵答嘅1分。The second one 好唔抵答嘅1分。第3條5分 ，which means that 4 plus 1. 4 plus 1 mark. The 5, well, with one star here, right? Which means that 4 plus 1 is 4 plus 1. 4 points. Finish? Finished? Cyrus, do you see your work? On your work. Now, all of you, have you all finished? Now, the most difficult part is on the explanation step where you have got, maybe most of you what will you tackle the problem? First of all, from him, you may locate the page. where you can find the source, right? The source is where? Where is the source? Page. Can you tell me where is it? 嗱 first of all, locate the page. Can you see this word? Okay.
Yes. OK。哦，唔係我出唔到去領書喎，我本書擺咗喺出，我本書擺咗喺出邊。我擺
即係邊個出邊？
唔係啊，我出唔到去拎嘢啊。
Oh, don't worry. You can also get this soft copy right in your Google Classroom. Don't you know that? Google Classroom.
我睇下有冇 download 先。
Here. You have found it. You can find it inside. Textbook 3B here. This. Chapter 33. Okay. So I would like to pick up one more example of your work. Great. More of you have got it. So I would like to pick Wang Yiklong's answer. Okay, as a start. Such that all of you can keep track of what is that. So the first one, what is the first answer? The first one is alkaline hydrolysis, or you can use the word saponification. Now remember, saponification, this step is only deal with the hydrolysis of triglycerides. Okay, but the alkaline hydrolysis is more general term. It is also acceptable and it's more universal to be used for some other ester. It's not necessary to be fats and oil. But you write down saponification is a very specific term. Point one. Point two, so you may find this structure, a very large structure. You are going to draw the chemical equation. That one mark is quite time consuming to score, I must tell. Very time consuming. So what you need to do, now, if I write like this way, can you score marks? Do you know? Now it depends on these. You know that it is in 2-to-1 ratio, right? Because this is referring to this. Okay. While for this one, you are going to refer to this, right? Okay. However, this one cannot score marks. Why? Because as said before, right, you may find the CC double bond inside. So we would never know the position of CC double bond inside. So which means that there is a chance of other isomers. Okay, there may be some other isomers. It's too general to be drawn like this way. So go back to the questions. If the questions show you the relative position of CC double bond, you are going to copy it down again. But not writing this. You take a look at question 16. Question 16 is quite strange, right? Because they just tell you C7H33 and C7H35. So if that is the case, the question will not ask for the specific location of the CC double bond. So you can write it in so a general way is also okay, but not for this, because for the reactant given, the carbon-carbon double bond is specifically stated. So you are going to follow. Do you understand? So this is one mark. How about what's next is on here. The hydrophobic tails of the soap molecules dissolve in grease, while the hydrophobic anionic has over dissolving in water. Now, remember, this statement is a very important statement to be stated at the very beginning, because it tells you the structural features of a detergent particle. Okay, do you understand? So this is point one. You are going to tell me what before the cleaning action of the detergent. You're going to tell why the detergent particle can serve its purpose. It's because of the very special structure. Now, the second point I would like to draw attention to is on the action, because you're going to talk about cleansing property. So the following, all those, they just tell you the cleaning action. Can you see that? From this to this, all those, they just tell you the cleaning action. The cleansing action of the detergent particle. Just take a look to see if he can score the other 3 marks. First of all, because of the fact that the hydrophobic tail is dissolved, can dissolve in grease, the iron dissolve in water, so water molecules attracts the hydrophilic head of the molecules and the grease is lifted off the surface of a fabric surface. Okay, this one is okay. You're going to tell the other action. They will lift up those oil droplet because for this, which tells you the action. Now it's quite different from what you know in reproduction. Don't think too much. Okay. So the oil is inside. Okay, while the surrounding it is water. While the detergent particle is on this, right? Okay, this detergent particle. You're going to tell something like this, okay? Now, this is point 2. Point 3, very important term. By stirring, the grease breaks up into tiny droplets. And because this part, the anionic head, all those carry negative charge, okay? So because I break down into several droplets like this, okay, chemically, they cannot come together because all those surrounding here is just negative. So there is repulsion. Do you understand? So there is repulsion in between. So they cannot come together. But the first case is that you are going to you are going to rub it, you are going to stir it, okay, whatever mechanical means in order to break that to make the oil, a layer of oil, break down into oil droplets. And we need that timing, right? Because once I break it apart, those negative charge oil droplets cannot come together again because of the repulsion of the same charge. Do you understand? So this is the key point. So you're going to repulsion of the anionic heads of the soap particles, okay? So you cannot. And then finally, one more point is to rinse, okay? You rinse away so you can wash because you're going to clean that. So afterwards, you are going to have a foam, right? Or emulsion. What you're going to do is to flush away those emulsion. Can you get a point? So all those parts, somebody may argue, Mr. Chin, well, you're just merely copying the book, right? But the question comes once you come to your own memorization, you are going to figure out what are the key points, right, of those. Simply speaking, you are going to have that 4 points. Okay, but of course, on top of this, something is missing. Now, what you just mentioned, you just cover it as a cleansing action because it is an emulsifying agent. It just tell you it is emulsifying, right? One important point is missing. What is that? Everything starts from what? Such that you can have the water molecules attract the ionic head, they help attract the ionic head or soap molecules and it will lift up the grease from the fabric surface. Do you know? How can we make this happen? So the prerequisite should be the water should wet the surface. Okay, the water can go into the fabric, and we will help that action of lifting up. So, what is the very first sentence of this paragraph? One important statement is missing. Start from everything. One important point is missing. What is
add soap solution into grease.
Add soap solution to the grease. Now, one property is not mentioned. What is that? 嗱，呢段嘢喺本書入邊抄晒㗎啦，係咪 ？Even though you look at the past paper, right? The marking will be this, but actually, one important point is missing in a sequential manner. That is the first step 0. Even though you copy all them down, you must go back to the very first step. Is the fabric must be wet, right? How can we wet the fabric more easily? I need the help of the detergent, right? So what is the first step?
Wetting property of soap.
Yes, the detergent particle, they will show it shows a wetting property. So of course you may put it here or you can put it here by telling it is a wetting agent by reducing the surface tension of water so as to wet the surface, fabrics, okay, more easily. So what you may find it quite strange. What is meant by wet? Wet. What is meant by wet? Now you go back to the previous pages. Okay, any description about the wet, you can borrow some of the saying. Now the wetting property. Okay, can you see that? They will help what? It is done by what? How will we say that the wetting, they will spread? Okay, the water molecules can spread through the, you may say that the water molecules, they can go through the fabric, or you can describe it a lower surface tension of water by disrupting the cohesion between water molecules. But it's fair enough, right? You will write down the wetting agent that can reduce the surface tension of water is already okay to me. You understand? So only by having this action, for the following steps, would it give a meaning? Would it give a meaning? Okay. Remember, the fabric should be wet such that it can help lift up, right? It can help lift up the grease particle once I have got the detergent. Now, second point, referring to the statements suggested by Cyrus, so you say that the oil droplet, they would have repulsion of the same charge such that they can form oil droplet. So this is not logical. It's not logical. Why? If you say that is the truth, which means that while you wash the dish, what you need to do is to spray with the detergent particle without doing anything, okay? And it can form emulsion. But it's not true, right? You have got for example, you have got a test tube of oil and water, and then you just squeeze some detergent liquid solution. So emulsion cannot be formed. Do you understand? Just like this. Oil, water, and then you add detergent particle. So what is the final? What is the next step? What happens to this? Will they form a foam? Will they form an emulsion? No. Without stirring, without shaking, what will they form? It is still oil in here, water in here. How about detergent particle? Do you understand? Do you understand? So the point, stirring is very important. Stirring, rubbing, that type of saying is important. Only by having this mechanical help would the oil droplet start to form and try to suspend into the oil water mixture. Only by having this, we will call it as emulsion. Okay, why? You just magnify the whole thing. So again, the soap particle will be having this. The negative charge will be outside. While in between, the structure will be this, right? I magnify the whole thing. Okay, it will be something like this. Do you understand? You got it? Now, so that's why during the long paragraph, some of you say that it's just a factual report, but partly true. But you are going to make sense of the whole flow of a mechanism of the cleansing action of the detergent, and I do hope this will help clarify some of the thoughts, right? While you write down the whole expression. Remember, put a star here for that B part. They will be tested every 2 to 3 years in your public exam. Okay. To end up the lecture today, I stress mainly on the answering technique for the detergent particle, right? You know, the 2 important points that you need to know. First of all, alkaline hydrolysis of saponification. You need to draw the structure of the fatty acid salt and the glycerol correctly. Second is on what? Is a cleansing action of the detergent. Do you realize that you need to tell the detergent particle process 2 important properties? One is wetting. Only by wetting, the water, the fabric can be wet. Okay, can be with water inside. And we will help serve another purpose is for emulsifying. While the detergent particle, they have hydrophobic tail and hydrophilic head. First of all, it will help dissolve into this, right? But the oil droplet can never be formed unless we shake it. So remember, you are going to shake it. You're going to shake it such that you can form a oil droplet. Even though you do not have any detergent particle, if you've got a layer of oil on top of water, you can still shake, you can still form an emulsion. But the emulsion is temporary. Finally, all will come together, water will come together, like this of light. Do you understand? But with the help of the detergent particle, because of this structure, okay, so we call it micelle, M-I-C-E-L-L-E. So it is a negatively charged tiny droplet. While those cluster, right? Those different oil droplets cannot come together again. with this action after shaking. And we call this emotion. Do you understand? So I do hope this will help. Not Michelle, is myself. Okay. Any questions so far? Do you understand? So if it's not reset, sorry about that. So I would like to end up the lecture now. I'll give you a break. See you guys next Monday. Okay, bye-bye.